Okay, homework M6C2 test electric fields, particularly question number 9, which reads, two identical suspended spheres carry a charge of minus 2.8 nanocoulombs, and each sphere has a mass of 6.5 times 10 to the minus 5 kilograms. The separation between the centers of the spheres is 2 centimeters, as illustrated below. Calculate the angle made by each thread with the vertical, so calculate theta. The first job we have is definitely make sure that your calculator is set to degrees and that it's not set to radians. Then we're going to add the forces to this diagram with weight mg acting vertically downwards, tension acting along the thread, and then we've got the two like charges repelling each other with a force determined by Coulomb's law of q squared because q times q if they're identical charges, q squared divided by 4 pi epsilon naught r squared, where r is the separation between the two charges. Once we've got the forces drawn, we can then draw a force triangle, which should be a closed triangle because they are in equilibrium. This closed triangle will have a right angle there, and the angle at the top here would be the same angle theta that we're trying to work out for this question. As it's a right angle triangle, we can label the sides hypotenuse, adjacent and opposite, and then use a tan function to link the opposite and the adjacent, which would be the weight and Coulomb's law, electrostatic force of repulsion. Substituting in these two forces into this tan function, we end up with q squared divided by mg 4 pi epsilon naught r squared. The last thing we need to do is just fill in the numbers. The charge is 2.8 times 10 to the minus 9 coulombs. The mass is 6.5 times 10 to the minus 5 kilograms. And the distance between the two spheres is 2 centimeters. And 2 centimeters converted into meters is 2 times 10 to the minus 2.